In this video, I am going to explain three different examples. First one, x is a random variable that has a normal distribution with mean mu and the standard deviation sigma. Asking to find the probability of x less than or equal 14. That means the area under the curve and left of 14. What is the first step? First step to find the z value of x equal 14. We know the z formula and here x is 14 and find the z value. It is 0.8. So corresponding z value is 0.8. So this is the standard normal distribution. Then you see the area under the curve and left of 14 is the same as that left of 0.8. That means probability of x less than equal 14 and the probability of z less than equal 0.8 are the same. Right. Now what is the next step? Once we convert to the z value and also we check the area, we have the less than area. Therefore, we can use the z table. Why? When you check your z table, you see the z table always gives the area left of z. Therefore, for this problem, we can use the table directly. It is the corresponding probability is 0.7881. So, probability x less than or equal 14 is 0.7881. Right. Now, let me explain the second one. It is the same random variable, but here asking probability of x greater than or equal 8. That means the area under the curve and right of 8. Again, we need to convert 8 to the z value. That means we need to find the z value for the x equal 8 as a first step. Yes, we know the z formula and here x is 8. So you can find the z value. Corresponding z value is negative 0.4. Then consider the standard normal distribution and now you understand the area under the curve and right of 8 is the same as that right of negative 0.4. That means again the probability of x greater than equal 8 and probability z greater than equal negative 0.4 are the same. Right. Now can you use the z table to find this? No, because first step find the corresponding z value. Then second step we need to check if we have the area left to the z value, right? But here we have area right to the z value. Again, as I show you just before, the z table always gives the area left of the z value. Therefore, we need to make this to the area left of z value. So how do we do that? So we know the entire area. So we can subtract the area left of negative 0.4. Then we can get the area right of negative 0.4. What is the entire area? It is 1. Therefore, we can write this in notation probability z greater than equal negative 0.4 equal 1 minus probability z less than equal negative 0.4. Now you see we have the area left of z, right? Z here negative 0.4. Therefore, now you can use the table to find this probability. Yes, this is the probability is what? 0.3446. Therefore, you can plug the numbers and the probability of z greater than equal negative 0.4 is 0.6554. Whenever you have the area right of z value, you always write 1 minus probability z less than or equal the same z value. So if you write down this without any density curves or graphs, you can write probability x greater than equal 8 equal 1 minus probability z less than equal negative 0.4. So you see the steps, the answer is 0.6554. Right. The last example. Here again we have a random variable x that has the normal distribution. Here mean is 78 and the standard deviation is 8. They are asking probability between 60 and 80. That means area under the curve and between 60 and 80. Right. What is the first step? Again, to find the z values for these two numbers. Because there are two numbers here, 60 and 80. So z1 and z2. Z value for x equals 60 is negative 2.25. For x equal 80 is 0.25. So probability of x between actually 60 and 80 is the same probability of z between negative 2.25 and 0.25. That means area must be the same as I explained before. Now how do we find this? Right, whenever you have area between two numbers, you can follow these steps. Yes, you see the highest z value, it is 0.25. So first we find the area, left area of 0.25, that is the highest z value. Then we subtract the area left of the smallest z value, that is here negative 2.25. So in notation you can write down this probability z less than equal 0.25 minus probability z less than or equal negative 2.25. Now we need to find the probabilities. Before you go to the table, check two steps. First one, you have z values. Yes, we have z values. It means z, right? We converted our values to the z, right? Then second one, do we have the area less than? Yes, we do have the area less than area, right? Or area left of the z value. Yes, both conditions are satisfied. Therefore, let me find the probability. First, z less than equal 0.25. It is here. Go to the table. It is 0.25. That is 0.5987. Right? So, we can write this 0.5987 minus probability z less than equal negative 2.25. Now we need to find this. Again, it is z and the area less than. So go to the table. It is negative 0.25. It is 0.0122. So you can plug numbers, then get the answer. That is 0.5865. Yes, you can do the same one using just without using these density curves. You see there are only few steps here. Probability between 60 and 80 is 0.5865.